In this video, we are going to answer the question, what is a logarithm? To answer that question, I'm going to go over the following example. 4 to the x is equal to 16. What is x? I'm going to try to solve for x. So when we use logarithms is when we're trying to solve for a variable in the exponent. By the way, this is called an exponential function when there's a variable in the exponent. Well, this one you can visualize is 2. 4 squared is 16, 4 times 4. All exponential functions we can put in what we call log form. So log form means that we are going to solve for the exponent. So I'm going to start with x equals. I'm going to write the word log. And by definition, they decided to put the base of this exponential function, which is 4, down below here. And the only number that's left is the 16, so they put that large right there. They call that log base 4 of 16. Again, this was the base, and this was the exponent. So let me write that. Okay, so what is something that has a base 4 with an exponent of x? The answer is 16. It means 4 to what power is 16? And we just came up with the answer is 2. So this is 2. So the right thing is the definition of log. So let's write down the formula. So the formula, what log, I'll do any letters here, B, A, and C. What log means is this. So it means the base is b, the exponent is alone. Remember, the exponent was the one that's alone? Equals the only letter that's left, which is a. That is what log means. That is the formula. Sometimes they call the thing on the left log form. And this expression or equation on the right, they call exponential form. So this is log form, and this is exponential form. You can always go back and forth. Any problem that's in exponential form, you can put in log form and vice versa. So let's do a couple problems involving logs. Let's go over log base 2 of 8. What is that? Well, if you can't visualize it, what you do is you make this equal to x, and you say 2, because that's the base, getting it out of logs, right? Like I did over here, the base is 2. The exponent is the guy alone, so that's the x, must equal 8. And 2 to the what power is 8, which is exactly what that means. The answer is 3. If you can visualize it, you don't have to write it out. Say you had this. Log base 5 of 25. Well, 5 to the what power is 25, because that's what that means. The base is 5. The thing alone is what's equally on the outside, so that's like the x equals 25. So 5 to what power equals 25? The answer is 2. This works. This is true since 5, that's the base, the exponent is 2, does equal 25. That does work. Let's do a few harder ones. Let's look at the example with some fractions. What if I had log base 3 of 1/9? What would that be? Well, let me call that equal to x. And let's get it out of log form. So the base would be 3. The exponent is the thing alone, right? The thing alone. Better equal 1/9. Well, what would that be? Well, it must be a negative exponent, negative 2. 3x to the negative 2 equals 1/9. So x equals negative 2. If you don't see that, you could change your 9. Let me do it right here. You could change your 9 to 3 squared, and this 3 to the negative 2. And so then you can clearly see that x equals negative 2. So I have one last question. What is a common log? Well, common log just means base 10. So let's do an example with that. If I had log base 10 of 100, that is an example of a common log. common log. And what is that? 10 to what power is 100? Well, the answer is 2. And again, if you don't see it, let's call that an x. Put it into log form. Writing the formula on the right again, so we can see it down here. So what is the base again? The base is 10. The exponent is the thing that's alone, equals 100. And so now you can clearly see x is 2. So when things are common logs, sometimes they will just call it log. So when there is no base, it means base 10, a common log. The answer to this one is the same above. 10 to what power is 100? So the answer still is this 2. There's an imaginary 10 right there. If you hit log of 100 on your calculator, you'll notice that you get 2. So all logs on your calculator, the word log on your calculator, is base 10. Let's do one last example. Log of 45. So go ahead and press log 45 on your calculator. You should get 1.65. Let's see if that makes sense. So again, the base, the imaginary base here is 10. So I'll just put a little 10 right there. 10 raised to the 1.65, right? Remember, the one that's alone is the exponent, better equal 45. Well, I do believe that, because 10 to the 1 power is 10. And 10 squared is 100. And 45 is in between 10 and 100. Well, that's it for today.